This is exercise 12, page 355. This is actually quite a hard one, and if you fumble around and figure out how to do it, then it makes sense, but this is a hard one to get started on. So the sum of three consecutive terms of an arithmetic sequence is 3, and the sum of their squares is 75, so find the three numbers. There are many steps to this, but the first thing is to write down what you know. You know that there are three integers, and the sum of them will equal, the three of them added together will equal 3. So you know that the difference is d. The difference here is d. So what we want to do is try to represent this in a minimum number of variables. So this term here we'll call a. This term here is a plus d. And this term here is a plus d, or a plus 2d. And those are our three terms. And if we add them all up, it equals 3. Now if we collect the terms here, we can see that it's a plus a plus a, so that's 3a, and d plus 2d, so that's plus 3d equals 3. And we can divide the whole schlemazel here by 3, and we get a plus d equals 3. Oh, sorry, a plus 3 a plus d equals 1. Now that's going to be very important, so I'm going to circle that, because we can now define d in terms of a, or a in terms of d. So that we've extracted from the notion that the three of them added together is 3. The next thing it tells us is that the sum of their squares is 75, and you might be tempted to make a series out of their squares, but the problem with that is that if, let's say you take four numbers that are in sequence, like 4, 5, and 6, well, their squares would be 16, 25, and 36, and we no longer have an arithmetic sequence. So we can't put those three numbers in a sequence. We just have to deal with the fact that the three of them squared added together is 75. So what are those numbers again? The first one we call a. So a squared plus the next number squared plus the next number squared will equal 75. Well, the next one up here is a plus d. That's our second term, that's our third term, right? So if that's our second term, a plus d, we already figured out that a plus d equals 1. A plus d equals 1, and 1 squared is 1. That simplifies things hugely. The third term here, which is a plus 2d, can be squared. So a plus 2d squared. So now we end up with a formula that looks like this. Actually, we're not going to put that in there. I go a squared plus 1 plus, rather than a plus 2d, which is complicated, let's recognize that a plus 2d is a plus d plus d. Now we already know that a plus d is 1. So 1 plus d, that's what our third number is here. That's 1 plus d squared. We can put that squared there if we like to. That equals 75. Now 1 squared, of course, is 1, but now this is dramatically simplified. So let's clean this up a little bit here. Get a squared plus 1 plus, let's FOIL this out for the sake of argument here. That's going to be 1 plus d plus d plus d squared equals 75. Now let's look at a here. I'm going to get rid of a. I'm going to define a in terms of d. Well, here we've learned that a plus d equals 1, and therefore d equals 1 minus a. If we subtract a from both sides, this becomes a new definition for d. Also, a equals 1 minus d. We can subtract d from both sides. And because we have a new way of looking at d and a, I can substitute in the a's for d's here, or d's for a's. I think what I'm going to do is substitute this expression in where the a is, and I'm going to get 1 minus d squared plus 1 plus all this crap. 1 plus d, I'm going to just say 2d, plus 2d, because that's these two d's here, plus d squared equals 75. And if I FOIL this out, actually I better collect the terms here because it's getting very messy. Plus 1 plus 1, so I've got plus 2 in here. I can subtract that from both sides. So let's get 1 minus d squared. I'm going to subtract that from both sides. Plus d squared plus 2d equals, I'm subtracting these two off the left side, subtracting them off the right side, I get 73. So let's FOIL this one here, 1 minus d times 1 minus d. And that would be, let's do it over here, 1 minus d, 1 minus d. And I get 1 minus d plus d squared. So I'll write that all out. 1 minus 2d plus d squared plus d squared plus 2d equals 73. Subtract the 1 from both sides. Oh look, these cancel out. Minus 2d plus 2d. So I got 2d squareds there, and I subtract the 1 from both sides. I got 2d squared equals 72. Oh, breath of fresh air, but not finished yet. So 2d squared, so is 72, so d squared equals 36, and d equals plus or minus 6. Now we can breathe. So if d is plus or minus 6, and it's pretty important to remember that plus or minus 6 is still the square root of 36. Now that I figured out d, I don't know my 3 consecutive terms yet. All I know is d. d is plus or minus 6. So we're going to have to take this up here. And what do we now know? We know the sum of 3 terms. We know d. We know that there are 3 terms. We don't know a. So we know everything in here with the exception of a. So we can use this formula to derive a, and that will give us the first term, and the next 2 terms are 3 consecutive terms spaced out by 6. So we're going to actually have to go to another piece of paper on this. I'm going to do it quickly because I realize that we're already at 8 minutes on this video. So S of n equals n over 2, 2a plus n minus 1d. And we can substitute in the stuff that we know. For the sake of argument, let's just use positive 6. We can use negative 6 as well if we decide to. Well, that might take a long time. So the sum is 3. There are 3 terms. 2a, we don't know what a is, plus 3 minus 1 is 2 times d, which we'll call 6 right now. So 3 equals 3 over 2a plus 12. We can multiply both sides by 2, and we get 6 equals 3 times 2a plus 12. And divide both sides by 3, we get 2 equals 2a plus 12. We divide both sides by 2, we get 1 equals a plus 6, and we get a equals negative 5. So if a equals negative 5, then our series should be negative 5, 1, and 7. And let's see, do those add up to 3? Yes, they do. And do their squares add up to 75? That would be 25 plus 1 plus 49, and that does. So that works. Now if we used minus 6 in this, we would end up with a minus 12 here, and a minus 12 and a minus 12, and that would be a minus 6, and 1 is a minus 6. And that would mean, yeah, that would just mean that our set would be like this, 7, 1, minus 5, and we would have d equals minus 6, and although it would be in a different order, it would be the same numbers and it would still work out. Oh, that was awful.